Let's look at how we represent a relation and quite in continuance with what we learned in the chapter dealing with sets. It is a similar form, that is the roster and the set builder form. The only key difference is that whereas in the case of sets we were dealing with elements as such, here also we are dealing with elements, but not the point that it's ordered pairs which are important. So uh, let us look at what these forms actually represent. Now, roster form, as it was in the case with sets, we just have to represent the ordered pairs and show that particular set. That is, it's represented by the set of all ordered pairs belonging to a particular relation. Suppose you have two sets, set A consisting of elements 4, 9, 16, and 25, and B consisting of elements natural numbers 2, 3, 4, 5, and as we can very easily understand, it is the roots of elements of A which are present in B. So the relation between the elements of A and B, that is A or B, is such that it's possible only and only if the root of A is equal to B. So you can write the relation as 4R2, 9R3, 16R4, and 25R5. Or you can represent it in the ordered pairs as such by putting it in brackets. That's the way we do it in the roster form. That is R. The relation R consisting of the ordered pairs 4, 2, 9, 3, 16, 4, and 25, 5. Now, what about the set builder form? The set builder form, as it was in the case of dealing with sets, we bring out the specific character or the defining property, and that is how the elements are defined or the elements are represented. So it's a relation R from set A to set B, and which is represented as R is equal to AB. That's ordered pair AB, where the first element, that's A, is coming from set A, or A belongs to A, is an element of set A, and B is an element of set B. And the key thing is that AB satisfies the rule which associates A and B. So that's the key point. As it was in the case of sets, the key point is that the rule is satisfied. That's the important thing. Oh, the property is satisfied, and the rule which associates, that's the key point. And you have to look whether the property by which the set is being defined is applicable. That's the important thing. Now let us look at the previous example in this particular case also. That is, we were dealing with the square roots of elements of set A, and here how will you put it? Naturally, it will be the relation is AB, that is the ordered pair consisting of elements of A of set A and B of set B, such that now we know that the elements of set A are already in the form of squares. So you can write it as A squared is an element of A, as A squared is an element of set A, and B is an element of B, and the key point is that B is equal to root A. Now, one important point which I'd like to mention is that now if the roster form was stated as such, and if you are asked to write the elements in the form of sorry, if the set builder form was, I mean, if the set builder form was given to you and you are asked to write the elements in the roster form, it can be easily seen that this much representation is not enough. You'll also have to mention that we are dealing with natural numbers, and it's between natural numbers such that 4 is less than or equal to uh, x squared, or the x, or x which is less than or equal to 25. So you'll have to mention which natural numbers we are dealing with. Only then you can specifically represent the elements in the roster form. So that's a important point which we should note. And another key point is that in the set builder form there's a particular deficiency, or one kind of representation is quite not possible, in the sense that if you are dealing with the distinct and unrelated elements, so you can see that if you are dealing with elements, elements a which comes which is in this lowercase a, that is small a, which consists of elements of set a, and if the set a is consisting of natural numbers like 2, 3, 4, and set B is consisting of elements of English letters like B, C, P, then it is very difficult of representing it in the set builder form, because as such we can't think of any particular relation or a property which associates these two elements, that is the elements belonging to set A and set B. Thank you.